Good morning and afternoon to everyone. Today we are going to talk about the research on multi-species front against climate change. From the typology study of the shearing shed, we've learned that beyond the social, environment, and economic impacts of shearing shed on the society, the shearing process itself, from the shearing position to the involvement of shearing tools, represents the intimate relationship and codependency between human and sheep. Based on the case study of shearing shed industry from global to individual, we have summarized with an overall failure on sustainable goals, such as a human-centric mindset and a neglect on biodiversity development. However, some successful experiments can also be observed, such as duality uses between human and sheep during different time periods, improvement to the employment discrimination, and design elements from the sheep's perspective. As a stepping stone, this typology study on shearing shed has taught us the development of physical embodiment that represents a multi-species understanding, underlining the importance of multi-species cohabitation under the ever-growing contemporary needs.
Moving on from our typology studies, our design proposal looks into a deeper understanding of multi-species cohabitation and how it can lead to a symbiotic relationship between humans and non-humans. When we first looked at Cook's River, it was pretty interesting to observe how the water body is presented as a dichotomy between human and non-humans. We observed the different types of conflict that happened throughout its long history, from the human-centric conflict regarding Thalassic colonization and later developments of rivers surrounding the native Aboriginal communities and the European whites, and to environmental awareness towards the river after post-war Australia. While the non-human ecosystem was considered as a necessary sacrifice for the growth of the nation in the past, the question is whether that still applies in contemporary context. Much of the environmental concerns around Coast River arises from own greed and actions, creating an antagonistic ecosystem between the human community and the native non-human inhabitants. Thus, our project aims to explore this interaction between human and non-humans and the mutual benefits that can arise from it.
As an opportunity for native pollinator and animals to take shelter, feed, and contribute to the local biodiversity, the Australian backyard garden is shrinking in size along with the city growth. Backyard garden has the ability to not only provide a more friendly spaces for non-human species to occupy, but also a chance for the immersive education through interacting with the nature. That is why it was once called the Australian dream. One of the main changes we found from the typology development is the denser the city, the smaller the backyard garden. The lack of environmental role of the backyard garden has not only led to an inefficient backyard storage space, but also a reduction in opportunities for co-living, which can be considered as a loss of Australian dream. From the comparison between the existing flooding condition with an estimation of the flooding condition in 2070 after the sea level changes, the data indicates that the current site location can be submerged during the high tide period. Water level oscillation in 2070 will be 1.4 meter to 3 meter above sea level during low tide and high tide, which means that the site will be constantly submerged even during the mid-tide period. From the speculation, this street around Hoston Park will be flooded during the high tide period. The nearby resident and habitation will be affected by the sea level changes, as you can see from the section. After finding the potential threats on the site, we looked into the procedures and additional improvement done by the local community and local organizations. Many related events are held by the local government to improve the current condition of a shrinking size in green spaces on land, like providing free gardening plant packs, services to collect green wastes in each residential. Other than that, there are also activities like litter picking on kayaks, bird watching, or bushwalking.
As we shift our attention from the human to non-human aspect of Cook's River, the metabolic diagram represents the existing food chain in both the land and water ecosystem. With the help of the two species we will focus on, which are the honey eaters and the mullets, a closed circle energy loop is created where a symbiotic relationship between the flora and fauna exists. So what's so important about the honey eater and the mullet? Firstly, as one of the primary pollinators in Cook's River, the honey eaters play an important role in transferring pollens to surrounding plants of both land and water ecosystem to grow, which proved to be crucial as a form of shelter and food source for other local wildlife. The honey eaters also help to remove water-dispersed weeds, which are antagonistic to the growth of mangroves and larger birds feeding on the river body. Similarly, the mullets help to digest leaf litters that mangroves shed, converting them into dissolved organic matter whose nutrients are crucial for the growth of these water-tolerant trees. As we combine the two information, we are able to identify the various behaviors and interactions that our focus species have on site. While the mullets see natural antagonism from native predators such as the whiting and herons, they alter their behaviors in response to these threats and utilize existing flora such as the mangroves as a form of shelter. In return, the organic waste excreted by these mullets after their diet becomes an essential source of nutrients for the mangroves to grow. Community groups such as the River Canoe Club helps to keep the water clean of inorganic waste which will threaten the ecosystem if left unchecked. The same form of analysis is done to the honey eaters, thus providing us with a better understanding of their behaviors, threats, and community efforts that aims to understand them better. From all the information, we summarize some of the potential threats and opportunities that we explored in our design. While much have improved due to the gallant efforts of the involved Cooks River Alliance and community groups, there are still concerns that persist. Many of these concerns stem from human-induced problems such as river pollution, deterioration of concrete lining, which increases the chance of flooding in future, the disconnection between park and water created by the fence, and of course, the imminent dangers and increasing frequency of high tide or king tide flooding. In response, our design proposes several opportunities. These includes improving the land-water connection to allow for convenience for communal waste collecting and water testing activities, to replace concrete lining with a natural barrier that is more resilient and beneficial to the surrounding ecosystem, and to build lightly so as to prevent obstruction to existing and proposed landscape while improving overall natural resistance of the site. We begin our early research looking at the existing structure that used to or still inhabits Cook River. We looked at how traditional Aboriginal clans utilize natural materials to build lightweight huts that could be easily repaired or adapted based on the population size and programmatic functions, which in the end could be salvaged as shelter materials for native wildlife beyond its end of life. We also looked at polygonal St. Peter's Church, which in spite of how much natural environment was cleared for the church construction, provides various opportunities for multi-species cohabitation. Lastly, we looked at the geometrical playground situated around Cooks River, how it could be used by humans and non-humans alike as a form of recreation and shelter from both the weather and natural predators. Based on our early studies of the sharing shed, we derived these 6 main concepts for our design. The first is to consider the proposal as a common between non-human and humans. Spaces are designed to consider the duality between the two inhabitants while creating opportunities for symbiotic relationship. The second aims to address the aforementioned threats and opportunities identified on the site and proposes programmatic functions that help to mediate the disconnected land-water relationship responsible for many of these threats. The urban edge between land and water is seen as an opportunity for social interaction and revegetative activities. Thirdly, the design considers the various community efforts in revegetation of Cooks River and the aforementioned diminishing backyard spaces of its surrounding residentials, which manifest as adaptable modules that can be varied depending on the type of landscape planted. The proposal further looks into adaptability to flooding, how programs and structures are able to accommodate a secondary function at different water levels for both human and non-human occupants. Last but not least, the design is depicted to change over time. Programs and modules can be added and subtracted from this overall design to match the changing demands and necessities of the community. Over time, the design is envisioned to be adopted to other parts of the river to address different concerns they possess, such as water quality testing, frequent floodplain, and soil erosion, while aiming to build resilience through the naturalization of river edges from the growing of the mangroves. The axonometry shows how the final design sits on site.
Looking at the plan of the modules, we have arranged a relatively more natural flow from the community to the module and to the river. For the section of the communal garden, to create an environment for native species to survive on site and be promoted by the local community, shrubs, pot plants, and small trees will be occupying 3 different spaces to create a variable environment for non-human species. Exposed spaces that could accommodate not only more than 50 people together, but also provide a backyard garden to the local non-human species The plant selection of the communal garden is a combination of small trees and shrubs. The dimension of the garden is also referred to the changing size of the backyard garden in the surrounding neighborhood to provide a more accurate and relatable precedent on the backyard garden for local residents. For the water modules, plant nursery and water lab are both placed nearby the river with platform going down to the river with a closer sight and interaction with non-human species. For the enclosed spaces can be used for private office uses, and it can also accommodate the services including toilets and storages.
The aforementioned structures illustrated in the section show how structures are adapted differently based on their different conditions and situations. For most of the park modules, which are mainly built above the flooding level, wood burner is used to further enhance the natural atmosphere to the whole design. However, modules which are exposed to the river water are built using concrete to prevent potential corrosion. In addition, these modules can be altered based on the programmatic requirements, thus allowing community users with the flexibility to add or remove walls depending on their demands and needs. The louvered walls are introduced to minimize bird collisions that happen quite frequently around Cooks River, while allowing for natural lighting and ventilation to occur within spaces. A second story can be added to provide better vantage points for sightseeing or bird watching. Lastly, as evident from the open steel rafters and the stilted steel structure, the modules adopt a skeletal structure to promote non-human inhabitation during times when the spaces are not occupied by humans. The community garden serves as a critique to the diminishing backyard spaces of the surrounding coastal residential and provides the community members with the option to be involved in the revegetation of the site. This will in then provide a more attractive environment for major pollinators such as the honeyeater to nest. As discussed, a lightweight structure is adopted to provide non-human inhabitation opportunities during times when humans are not present. As such, the community garden serves as an educational hub aiming to foster multi-species understanding. The community kitchen provides foraging opportunities for both human and non-human inhabitants. The function complements existing policies to promote revegetation of native plants while allowing both community users and groups to be directly involved in their own food production. Furthermore, the native plants attract surrounding pollinators, thus enhancing the aforementioned revegetation efforts, while providing food source for said pollinators, which include various invertebrates and the honeyeaters. The consideration between human and non-humans is also adopted to other modules. Here in the plant nursery module, rainwater is seen and considered to be mutually benefiting both inhabitants. In addition to its functional purpose, the rainwater harvesting roof doubles as a birth bath or drinking fountain for the native honeyeaters to rest. Furthermore, collected rainwater can be used for either plant nursery purposes or the compost bin, in which leaf litter collected from the nursery or its surrounding is decomposed into usable fertilizers. Once the mangrove seedlings have grown large enough, they are moved to the outdoor modules, which can be further adapted to suit the growth of the mangroves. Lastly, in addition to the human and non-human relationship, the water lap and deck considers the different tide levels into its design. During low tide seasons, the water lab functions as an educational aquaponics system for researchers and community members, while providing juvenile mullets with a safer environment to grow. The outdoor deck are exposed for public use and functions as both a communal gathering space and a more convenient means for volunteers to collect water for quality testing. Here, the deck also provides the community with opportunities to plant water-resistant flora such as the native sea rush. As tide begin to rise, the aquaponics system allows in river water, which creates opportunities for the water lab to determine the system effectiveness in addressing the water quality problem in Cooks River. At the same time, the submerged seedings and aqua landscape act as shelters and food source for young juvenile mullets. Along with it, we propose these smaller mobile units that can be used to collect leaf litter and inorganic waste around the site. These leaf litters could then be either used by human inhabitants to create fertilizers, or for the non-humans on site in the case of food source for the mullets or a collection of nest building material for existing honeyeater and other avian species. The section shows a general understanding of how the unit functions, which can further be modified to suit different conditions and environment. To summarize, the proposal delves into the multi-species conditions of Cooks River, thus understanding the existing threats and opportunities that can arise. The proposal aims to foster a democratic and symbiotic gathering space for community members, various volunteer groups, and the non-human inhabitants of Cook River, thus adding educational, social, and functional values that can help to foster this mutual multi-species understanding. The design pays respect to the natural environment of Cook's River by adopting an open light structural system, which opens up more opportunities in which native wildlife can inhabit the space when are not being used by humans. As a final conclusion, the architecture serves as our contemporary desire to understand and cohabit alongside many non-residents of Cook's River who fell victim to our capitalist desires for progress, and a united stance against the ever unpredictable and imminent threats of climate change. Thank you.